Okay, hello, this is Dr. Janes, and I'm still doing some experiments with high voltage and water. And here I built a special little device here where it's got a screw up here, and I put a rubber thing on top so I don't get shocked, so I can screw it while it's got high voltage on it. There's a high voltage electron here, and another screw that comes in the bottom, and it's sealed where I can put high voltage there. I can create a tiny little spark gap in between here, between this screw here and the bottom here, and I can screw this top part up and down like so to change the spark gap length. Okay, and oops, I'm screwing it the wrong way. There we go. See, I can screw it up. So now we have a bigger gap, and we'll try to measure the breakdown electric strength of water that I'm using with a different method with this spark gap here, and using higher voltage, because higher voltage is nice because then you can use spark gaps with it. The other thing, it's blowing my plates apart when I was doing some high voltage sparks on that. So I can put less energy and put a higher voltage and get a bigger gap. Anyway, so we'll measure what the dielectric breakdown is using a different method and using higher voltage. And I'm going to use my, I don't know if you haven't seen the video where I built this thing, and I provide free 3D printer downloads from a Thingiverse if you want to build one of your little high voltage handheld power supplies or stun guns or whatever. And it's got a little switch here, turn it on and zap things or whatever. It's very handy. It's made with the Chinese 400 kV voltage multiplier. That's this guy here, this little contraption. They're pretty cheap, but it's not really 400 kilovolts. We'll measure that and show you it's a lot less, but it's enough for our experiments. Okay, so let's get going. We'll measure the dielectric strength of water using a different method, a little underwater spark gap. Very cool, huh? Okay, so we have our high voltage probe here and our high voltage generator and DMV, digital voltmeter, DVM I mean, and this 1000-to-1 probe, so it's about 12,000, a little bit less than, about 12 kV, a little bit less. It's kind of drooping when it runs for a while. Try it again. Okay. 11,500. Okay, so we'll use that as the voltage, and we'll see what the breakdown is. Okay, so I have a spark gap that you can screw out, and the bottom plate is in an electrode, and so I can precisely measure what the distance is. And here's a capacitor, and let me so I have my high voltage charger. Let me charge this guy up. I have a charging resistor, but it's really not that good for charging. Okay, and I'll charge this guy up with our high voltage guy here, and let's try discharging it through our spark gap and see if we get a spark under the water. I'll try that again because I think it charged down when I touched it with my finger. Okay. Take a look in there. Try it again. Turn off the light here. Okay. I don't see the spark right now. Huh. Okay, there's all the way down. So I'll bring it out like a half a turn maybe. Okay. And we'll charge it up. See if we get a spark under the water. Okay, I think it sparked that time. Okay, I'll take a look again. Yeah, I'm definitely getting this underwater spark. Okay, so that's a half a turn. Okay. Get it focused in. Huh. I don't think it's sparking every time. So we're probably about at the breakdown threshold. 50% of the time it's sparking. Where did it go? Okay, now I have the spark gap at about a quarter turn. I'll try charging her up and discharging it down here. There we go. Looks like we're getting an arc in the water. Oop. Okay. Okay, so somewhere between, again, yes, I'm just discharging it by touching it down there. It's definitely producing a flash under the water consistently at this. So somewhere between a quarter turn and a half a turn of the threaded, this is a 8/32 screw, so there's 32 threads per inch, so we can figure out what that distance is in millimeters and calculate the breakdown hold-off potential, or the dielectric strength of, what is this? Is there some kind of white stuff forming in there? We want to convert 1/64 inch to millimeters. Okay. And so 1/64 inch is about that many inches, and it's about 0.4 millimeters. Okay. And so that is about where our arc breakdown started happening underwater, because remember the screw is 32 threads per inch, and we're half a turn about. It's about the limit of where it would hold off the voltage. Okay, so we had about 12,000 volts divided by 0.4 millimeters. So that's volts per millimeter, which should be the same units as actually I want to convert that to megavolts. And so that's about 30 megavolts per meter, if I'm doing the math right. Okay, and I think the water breakdown, so 30 megavolts per meter. Dielectric strength of water. Okay, Good. Okay, remember this is in megavolts per meter. So the dielectric strength of water, where is it? Distilled water. It's about 65 to 70. Okay, so we're within an order of magnitude there because we measured about 30 megavolts per meter. My calculations were correct. Okay, so very cool. Anyway, this is Dr. Janes, and thanks for watching.